erase this. So, 6 first. Was it, wait, yeah, this is, okay, this is too many numbers. 6. So, the point, they give you a point, and they say it's an approximate solution to that equation. Oh, this is, okay, so this is supposed to be the chemistry one, like the example I went over yesterday.
Yeah,
Which was 2.5 moles per liter times X liters plus 7.25 moles per liter, so it's concentration, times Y liters was equal to 10. And did they still say it's equal to 10? Yeah. So it means that so this solution, 0.811, is X and Y. So that approximate solution means that you used about 0.8 of a liter of this solution, of that concentration, and you added it to just over 1 liter of that concentration. So then you ended up with about 1.9 liters of solution, and in that solution, there was 10 moles of acid. Think of moles as a count of molecules. It's sort of like that. It's not exact, but it has to do with that. So there's a total of 10 moles of acid out. So the domain, what is the domain? What kind of numbers can go in? Real numbers that aren't negative. Non-negative reals. Yeah, non-negative real numbers you can use. And the y-intercept of the graph would be when x equals 0. I gave you that yesterday, right? Didn't we graph it?
Yeah.
What did we end up with up here?
It's about 1.3.
It was like 10 over 7.5. Is that right?
Oh, yeah.
Because this number here would have to be 10 over 7, I'm sorry, 7.25. So it's about 1.3. So that would be 0, comma, whatever you choose for that number. Because at this point here, you have 0 liters of solution X. Then, is that good enough? Then, whose was that? Whose question? Yours. Is that good enough explanation? Okay. Seems like that's where you let off on your homework, huh? Okay, 11. How many pounds of cashews at $3.29 a pound should be mixed with peanuts at $1.79 a pound to create a mixture of 5 pounds of nuts worth $2.29 a pound? Yeah, this thing's always a bugger, writing that out. So if we used C and P for cashews and peanuts, so if it's, I think it helps if we put units in there, because if the units don't come out, we know we're wrong. And if the units do come out, there's a good chance we're right. So if we use this form, AX plus BY is equal to C, and then the A value is going to be the price, is it $3.29?
Yes.
Per pound times the pounds of cashews would give you cost. So then I don't know, let's just keep going. And then what are peanuts a pound? How much? $2.29?
179.
Oh, $1.79? Okay. That's all right. So $1.79 per pound times the number of pounds of peanuts is going to be equal to what?
229. $2.29.
$2.29 per pound, and how many pounds?
5.
Times 5 pounds. So the pounds will cancel here, won't they? Uh-huh. And then we have money. And here, the pounds will cancel and we have money. The pounds will cancel and we have money. So what's 5 times 229? 1145?
Yep.
So there. So if you pick all cashews, you're gonna get like 3.5 pounds or so. If you pick all peanuts, you're gonna get about like 6 pounds or something like that. Otherwise, everything is combinations in between. So how many pounds of cashews should be mixed with peanuts? I mean, I think that's as best we can do right there. This is just a general answer. And there's lots of solutions, right? Because you can weigh down to, ounces and grams and stuff. So, this is kind of like, it's not a discrete function. But if these are cashews, not peanuts because that's listed second, these are cashews, if it's all cashews and 0 peanuts, I mean, this out here is like roughly just, I don't know, let's just say it's 3.5 pounds. If 3.5 times this is equal to this, just as an estimate. And then up here, this is like 6 of those to make that. If this is 0, these are all the different combinations. And they doesn't need to be exact. I just want that graph for you to kind of look at it because it leads into the next lesson that we're doing. If we hold C equal to 0, P is about 6. It's 11.45 divided by 1.79. Do you see that? And vice versa. If P is held 0, this number here is 11.45 divided by 3.2. Are you sure you see that? Because otherwise I just fly right through this. You know what I'll do. You're okay with that? You're not nodding your head. You are okay? Okay. So then 16, graph y is equal to the square root of x squared minus 4 on a calculator.
I didn't know how to do it. Okay.
Oh, okay, math, right? So if you go with the y equals, and then, I think it's math, right? No, what am I doing? Square root, not absolute value. So you do second, and then the x squared key. And then x raised to the second power. And then you have to move the arrow over, and then you subtract 4. You got it into the calculator? What's it look like? It's like this, right? Oh no, oh, that's right, it's like this. But it's shifted over to the right. It comes down at x equals 4. Is that right? Ooh. That's what you got.
Yeah, that's what I'm.
What's your graph look like? Why is it doing that? Got a little curve. Why? This is the square root, right? Oh, of x squared, not x minus 4. Ooh, okay. Square root of x squared, yeah. If it was going to be like this, then it would just be over here at 4, like that. But because it's x squared, like this here, Jeez, what times itself is equal to x squared minus 4?
If you do square root of x minus 4, it only goes to the right. It doesn't.
Yeah, if you do x squared minus 4, it just goes to the right.
I mean, no, if
No?
you do the square root of x minus 4.
It just goes to the right?
Yeah. It just goes, it's just like one of the blue ones, but it only goes to the right as far as it goes.
That looks curved too, doesn't it?
Yeah, and it goes.
Yeah, you're right, yes, you're done backwards. Yes, you're right, it's not like this. Yeah, boy, don't listen to me this morning. We're gonna talk about graphing, oh, this isn't gonna be good. I'll get it straight. That's right, that, because the root function is this. This just moves over here to 4 when you do that. Okay. So this, because that's minus 4, it did this, right?
Yeah.
Nothing times itself is equal to x squared minus 4. Because of that. So why does it do that? Why does it go both ways? Because if you square this, that gives you x squared minus 4. And then you get that squared. Yeah, so in order to get back to this, you have to take the square root. And when you do that, you have what's called plus and minus. Because you have a variable underneath the radicand, you always will have a positive and a negative solution. So I just did that so you could see when we get to this, we have to have a positive and a negative. Once you have a positive, that's this one. And when you have a negative, that's that one, right there. It's like, do you guys know the equation of a circle? Have I shown you that before? Say yes or no.
I don't remember.
You don't remember? Yeah, I don't know that we have. The equation of a circle is equal to this. R is the radius. So, to give you a kind of a quick one as to how it comes into being, let's say we choose a radius of 1. That makes this real easy to do. X squared plus y squared is equal to 1. 1 squared, which is 1. So if we look at combinations, if x is 0, what does y have to be? Has to be 1. So there's a point. But it could also be negative 1, right? So you have a positive and a negative answer, just like this here. So there. If y is equal to 0, what does x have to be? 1 or negative 1. So here. And then there's all of the others that, well, this isn't real nice and pretty, but there are all of the other combinations. So you like if x is equal to a half, 1/2 squared is equal to a 4th. And then I need a number times itself that adds up to 3/4, which would be like 3. 3/4. What number times itself is equal to 3/4? Would be like the square root of 3 over 2. And the square root of 3 is a little bit smaller than 2. So this is a number a little smaller than 1. So you go over to half and you have something up here. But then there's also the negative of it. And if you do all that over and over, you get all these points. That's the equation of a circle. So if you go into the graphing calculator, you can only graph half of it. And what you can do is take this equation here, and what we have to do is we have to write it as y equals to put it into the graphing calculator. So subtract x squared. What I'm doing is I'm trying to work it down to slope-intercept form. We get to there. And then what we have to do is we have to take the square root of that and the square root of this. And that's going to be plus and minus negative x squared plus 1's square root. So now, if you go into your graphing calculator, and in y sub 1 you enter the square root of negative x squared plus 1, and then into y sub 2 you do a negative square root of negative x squared plus 1, and graph that, you'll get a cute little circle. And if you want your circle to be bigger, you just got to change that to some radius. Let's say you want a radius of 5. You change this to 25. You're not punching your calculator. Yours didn't work. What?
Look what I made.
Oh, well, you don't have the bottom in there, do you? Well, that one's plus, and that one's minus, right? Or is that the minus, or is that subtract? Make sure you use, is it this one?
Oh, I didn't do it.
Is it the minus in parentheses? Really? So you have to have a negative x squared,
I got it.
and then it's plus 1.
I got it.
You got it now? And then you have to do the negative in the parentheses, and the square root, and negative in parentheses, x raised to the second power plus 1. And then when you graph it, it'll go over the top, and the red one will be on the bottom. But it won't look like a circle because you have a weird
Look what I made.
scale. Yeah, that's different. What you did there, you typed it in differently.
Oh, I just did a bunch of other stuff.
But what you can do is you can change your window, you know, to like a -2 to +2. And then graph it, and then it looks a little bit more like a circle, but it's kind of oval. So if you hit zoom, and it says, I think it's z square, it'll make your screen so that it graphs with a square dimension. And then you get a really pretty circle. Yeah, so if you want to see, like, when we do inverses and such, and you want to see reflections and things like that, if you graph on z squared, it'll give you a really nice look. And you got yours entered? Yeah, and then hit z squared, go to zoom, and number 5. Yours is in there. Yours is in there? You got yours in there? You got all kinds of stuff going on there, don't you? Looks like you have 2 circles.
Yeah.
Yeah, what else when you graph them?
Big circle.
Made a triangle.
Mine looks like
Well, you got the circle, and if you go to his, you're messing with stuff now. All right, well, let's look at the next lesson. Graph of ax plus by equals c. So the first thing they had was negative 5x plus 2y is equal to 10. They want you to graph this. So the steps to this are kind of threefold, really. You find the x-axis, or the x-intercept. You find the y-intercept. And then you test one more point to make sure that it fits onto the line, and then you're done. So step one. Find the x-intercept. The x-intercept is going to be where that line crosses the x-axis. And y will have what value? 0. Yeah. So if you take a table of values and you set y equal to 0, you just go to this equation here, and x is going to have to be negative 5x plus 2 times 0 is equal to 10. So that's going to be 0. We don't have to worry about it. So negative 5 times what number is equal to 10? Negative 2. There you go. Second step, find the y-intercept. And that's going to be when x is equal to 0 because it's going to be on the vertical axis. So then we just look at this equation. Well, it's going to be negative 5 times 0 plus 2y is equal to 10. So, yeah, so y has to be 5. Yes, exactly. So there are your two intercepts. And then we just have to make sure that we did our work well, and we can check that with a third point. So I'm going to look at this as negative 2, 0, and 0, 5. So right here. So this is going to be, that's going to be an approximate graph. So if I look at it, it seems like if I went to -1, that this would be something like, 2.5 or 3, just roughly. So if I go and I check a point, if I was to check another point, if I put a -1 in here, so -1 times -5, or -5 times -1, and then 2 times y would be 10. So this is 5. So I need 2 times something to get 5 more. So it'd be like 2 times 2.5. So you just do this in your head. So if I had -1, that would have to be 2.5, and that sure looks like that's on the line. So I'm done. That's a rough graph, or a rough sketch of a graph. And that works. And you may say, well, why don't we just use the graphing calculator? Well, because there are going to be times when you take tests where part of the test they're not going to let you use a graphing calculator. Or this might even be faster in some respects. Or it might be more useful to be able to have it on paper in front of you. But you can always go to your calculator and check it. But in order to go to the calculator, you need to change the form of the equation, right? Yeah. So, but no, on the ACT and the SAT, don't you get Desmos? I swear you do. Who's taken the SAT or ACT? You took it. Did they give you Desmos? They just gave you a TI-84. Could you use your own TI-84?
Yeah, that's what we use on
In the PSAT, but there was no embedded Desmos, huh? Okay, maybe I'm mixed up with this. I know some states for their standardized testing, like our peaks. In other states, they would let you use Desmos. Were they letting you use Desmos? You're Washington, right?
Right.
So, were they letting you use Desmos on those statewide tests, do you know?
Yeah.
Okay, so Washington lets them, but Alaska didn't. I know Wisconsin did. But that's as far as my knowledge of that goes. Anyway, if you're gonna change that so that you can plug it into the calculator, what do you have to do?
Y equals.
You have to write it as y equals. So let's change that to the slope-intercept form. How do you do it? It should just go like this for you guys at this stage of the game. What do we do? Add 5x, and then divide by how much? 2. So y is equal to 5 halves x plus 5. Slope-intercept form, same equation, just in a different form. So for example number 3, they ask you to look at a whole bunch of different equations. And one way that you can see if two equations are true are by changing them back and forth between slope-intercept form and standard form. If you look at example 3, though, on the bottom of page 165, all of those are, they're in something that looks like standard form. Which one is not standard form? Which one's not in standard form? Of these 4 equations here, which one's not standard form? Yeah, the first one, why not? There's a decimal point there, yeah, it's gotta be integer values, whole numbers. So,
What form would that be?
yeah, well, I don't know, the form is just not in standard form, because by rule, A, B, and C need to be integer values.
So you
Yeah.
can't have fractions either?
No, you can't have fractions either, so 5 halves x plus 2/3 y equals 27 is not standard form. So, yeah, so there's some stuff that we did in Algebra 1 where we would take these that were not quite in standard form and we would change them, but I did not emphasize that. It's a finer point that, you can deal with it when you need to. But if you look at those 4 equations in example 3, you've got, 4x plus 1.5y is equal to 12. 8x plus 3y is equal to 12. Are these the same?
Yeah.
No, because you don't double the C.
Yeah, this doesn't get doubled.
Oh.
So no, these are not the same. Yes, times 2 times 2, but this would have to be 24 to be the same. So then if you look at the 8x plus 3y is equal to 24, that's the same.
Mm-hmm.
And if you look at 16x plus 6y is equal to 12, well,
Yeah.
take half of this, and half of this, and that turns into a 6, doesn't it?
Yeah, but none of them are equal.
Yeah, so these two are not like the others. It's like Sesame Street. Which of these is not like the others? Which of these does not belong? Remember the song? No, you didn't watch Sesame Street?
Yeah, of course I was.
Okay. Second example, x plus 0y is equal to 3. X plus 0y is equal to 3. So I'm going out of order. This is example 3. Now we're on example 2. What's the graph of that look like?
Oh, x equals 3.
X equals 3. Yeah, that's x equals 3. So it's going to be
That's great.
a straight line going through where?
Up, 3,
Up and down.
undefined.
It's undefined. It's an undefined slope, vertical line. Is it a function?
No.
Not a function, yeah. How about horizontal lines? Are they functions? Vertical lines? Yes. Or, I'm sorry, vertical lines, no. Horizontal lines, yes. Because a horizontal line passes the vertical line test. If you draw a vertical line, it only passes through the line in one point.
Oh.
So anything which is not vertical is gonna be a function if it's straight. There are, sometimes things do this. We can graph that kind of thing. The circle that we did, is that a function? No, because if you draw a vertical line, it goes through 2 points on your equation. So it's an equation, but it's not a function. So this is not, because of this vertical line. Those 2 points, that means you have 2 answers for 1 input. Doesn't work. Okay, that's that. So, do them all, Logan. 2 to 7, 9, 12,